Okay. Hello and welcome to the CIC Start Online webinar here at Glasgow Caledonian University. My name is Branka Dimitrijević and I will moderate today's webinar. If you are joining us for the first time, I need to say that our webinars disseminate outcomes of feasibility studies and academic consultancies that have been undertaken by universities involved in our project. The project supports collaboration between 7 Scottish universities and small to medium-sized enterprises operating in a construction sector in Scotland. The focus of the studies is on sustainable building design and refurbishment. The project is funded by European Regional Development Fund and the Scottish Government's CIC program, which is currently managed by Scottish Funding Council. This is a live event, so if there is a fire alarm, we will have to stop, but you would be able to watch the video recording of this webinar tomorrow. We plan to finish presentations around 1:30, but you can start asking questions by using chat facility anytime during the presentation. The questions will be answered after presentations and we will probably close the webinar around 2 o'clock. We now also offer live transcription services as part of our online broadcasts. The presentation is transcribed live in a pop-up window as the webinar takes place. By providing this service, we hope to make our webinars accessible as possible. The instructions are provided in a login email that you have received this morning. So today we will learn more about the outcomes of a feasibility study entitled Closing the Gap Between Design and Build. The speakers at today's webinar are Julio Bros-Williamson of Edinburgh Napier University and Dr. Cameron Purdie of the Morrison Partnership. I would kindly ask now Julio to start with the presentation.
Thank you very much, Branka, and thank you very much for yourself and the Kickstart team for giving us this opportunity to talk about this feasibility study. It's clearly something very important within the building industry at the moment. As you well said, the title of this is A Gap Between Design and Build, but focusing on Scotland, talking about Scottish issues, and looking at how our compliance issues towards 2020 building regulations. As a means of contents and just as a guidance on the different slides that we'll be talking about, this is just really a list of the topics that we'll be touching on, starting off with an introduction and looking at the existing literature and the purpose of the study. And also looking at the origins that we've identified through our literature and also our experience of this gap, and then looking at maybe an approach to shrinking the gap, and finalising with some conclusions that I think are important to consider for now and for further research. As Branka well commented at the beginning, the partners in this feasibility study are the Morrison Partnership, who are architects, CDM coordinators, and also have an extensive experience in building and designing. So it's important to their experience in this feasibility study. And also ourselves from the Scottish Energy Centre, which is part of Edinburgh Napier University. I think just as an introduction, it's important to look into how building regulations have been more stringent. They've started to shift in areas where there's better standards. There's better models of constructing and designing, and it's important that that's addressed. Also, the living conditions have obviously improved. Thermal comfort is a big issue these days, so there's a lot of concern of achieving this, both on the design of buildings and also during the occupation of them. So really the objective of what we're trying to look into, and the report that we produced was trying to kind of talk about, was really to make buildings better places to live, and also look at ways in which that can be achieved at the design stage and other stages of the building. So it's down to compliance of building regulations, and also looking at occupancy and thermal aspects of the occupants. I mean, a lot of these elements will be touched on in this presentation. How energy efficiency and the rating of buildings has become quite an important way of predicting how buildings are to be occupied and how to work. So that's been quite an important element and benchmark that a lot of people take on board at design stage. And also obviously technical standards, handbooks, technical details that have also been very important, how people use those as a guide during design, or as a benchmark as well, is also important. And the way different literature and different guidelines, like the Sullivan report back in 2007, how that has been really important in the way policy has been framed around, and how people's way of imposing standards and building regulations has been quite important. And obviously the European Union has been important as well in imposing a lot of these guidelines. But really the study looks at the possible sources of this gap, and which we will identify later on. And it's this gap between what's been designed during a long research in terms of design and the occupant, and how that's been transported over to the construction stage, and also during the early occupation. So there's been an identification of a big gap, especially in the energy use of these properties, and we'll be looking into all types of buildings in this report. So really it's this comparison between the design and build, and identifying why this gap is appearing, why the energy that's predicted is not the same as the actual one, whether it's the first year of occupation or after 2 or 3 years of occupation and later on, which is a big concern in the building industry. So we're identifying why this gap is appearing. I mean, some of them could be led around design aspects and the quality of design, complexity of it. It could be during construction. A lot of people think it is purely construction, and that is the big problem, and the skills around it. But it could be also the occupants. So we try and kind of identify those. But really it's creating this awareness of the gap, trying to give information towards the different professionals that deal with buildings at design, construction stage, handover stage, and really making these points quite clear. We're trying to look into not just one sector, which a lot of the literature we've been identifying constitutes just in one sector. We're trying to look into new builds, retrofits, and non-domestic and domestic. So that's something that will be quite interesting. I'll now pass over to Cameron Purdie to continue.
Okay, thank you, Julio. I'm going to take through the next few slides. Good afternoon, by the way, to all who are joining with us. I'm going to take you through the next few set of slides which try and establish the reason behind why we set forth on this path of this study. And on this particular slide that we're looking at just now, it begins to introduce further down at the bullet points round about here some of the issues that we early established with our research work. First of all, we identified that for most buildings you would either be in the category of new build or in refurbishment. The second area was whether or not you would be in the domestic sector, or we've called it commercial. You might, if you wish, read for that non-domestic, but it does have some importance to be able to call it commercial, because it widens out the building types that are not covered by much of the research work that's going on within many of the housing-based organisations. And many of those organisations, such as NHBC, Good Homes Alliance, and also the Carbon Buzz website, a lot of those organisations have done a huge amount of investigation and some preliminary reports about this whole issue of a gap between design and build. And we looked and we've reviewed at some of that literature. But what we wanted to do was broaden that view outside of housing to look at the whole area of retail, offices, industrial, commercial premises, schools, factories, because to our understanding there was very little focused research going on in that area. Most of it was in the area of domestic. So it is important that we're looking at both domestic and the commercial fields. And the other element that we wanted to look at was the different stages within the building process. You might, if you like, try and imagine the RIBA plan of work as a guide, but we have just summarised that into three principal areas, one being design, then construction, and finally the management section. The design section will really take everything that will be pre-contract. Now that could involve strategic decision making, it could involve detailed design and specification. The construction section or part of the process is really anything on site. And the final one in management is trying to look at not just commissioning but handover, operation and maintenance. And those three elements are now summarised in our next slide, which indicates to you the 12 streams of research that we believe need to be further investigated. Those 12 strands cover the types, the classification and the process stage that we've been speaking about. They're all different. You can imagine, I'm sure, that for example, if you're working in the domestic sector and you're doing SAP calculations, well, that's completely different from working in the non-domestic and you're using the SBEM calculator. Equally, you have the end user. The end user in the domestic sector may be someone in a housing association flat. They may have learning difficulties. They may not be able to know how things work or how they're meant to work. Then you go to the commercial side and you have someone who is a building maintenance manager, and that person may be well acquainted with how the systems operate. So there is a variety within these whole 12 sections of the proposal that I think require individual and specific streams of research. There will be crossover, certainly, but I believe these are 12 good, solid areas which later on in our presentation we are proposing will be a substantial outline for further research work. 12 good areas to look at. One of the things I want to draw your attention to is the Carbon Buzz website and the Carbon Buzz information. Julio and I are mindful that Carbon Buzz has done a great deal of information and presented quite a lot, and it is available freely on their website. It's an RIBA and CIBSE platform which provides information about designed and actual energy consumption and of course CO2 emission. And in that website, if you look at it in a bit of detail, you will discover that they are already identifying, albeit just simply by tracking the comparison between design and actual, they are already suggesting that in some areas they're looking at possibly 50% greater CO2 emission or energy use requirement in some buildings, even 200% over the predicted use in others. Those are mostly in schools and offices. Residential is a little closer, but the one outstanding, astonishing problem is in the industrial sector. Although they don't have much data in that area, we are looking at somewhere in the region of about 10 times greater use of energy or of CO2 emission than was predicted at the design stage. Now, we can't place too much emphasis on that because there are very few examples on the Carbon Buzz website for that sector of building, but nonetheless, it does highlight the issue that a great deal of the research that we hear about within energy and sustainability is very much focused on domestic, but the real culprits are non-domestic. And that is an area where I think Julio and I, from our research and discussion and thinking, we want to address that area and see what moves can be made by further funding to look into the reasons behind the disparity between designed and actual energy consumption. Moving on to our next slide, the whole origin of this research project, it really began because of a chance comment that was made in our office at the Morrison Partnership about 4 years ago. We had just had a CPD presentation on underfloor insulation, and we were somewhat jokingly querying whether or not the insulation, which was one of those clip-in insulations, would actually survive delivery to the site, survive handling, positioning, and whether or not it would be able to provide the required energy saving in the building. Because we thought that perhaps even during handling on site, bits of it might get chipped off, and so the actual fit and actual outcome of energy consumption in the building would be much worse than what was the design prediction. And it was really because of that chance remark that I sat down and started to brainstorm what were all the different things from start to finish on a building project that were affecting the whole idea of delivery of predicted energy models. And it was really out of that that we approached a number of organisations for funding, and eventually we're very grateful to CIC Kickstart for giving us the funding for Julio and I to look at this research work, because we feel it is very important, and we feel that there is much, certainly as we're going through the rest of our presentation, to share with you that is quite worrying in terms of achieving some of the targets that are being set. If you look at a target that, for example, is being set in Scotland, because we are wanting to have a Scottish dimension here, that's quite an onerous target. It is obviously greater than the UK target of 34%, but 42% reduction in CO2 emissions by 2020. When you consider that 50% of the carbon emissions in Scotland are coming from the construction sector and from the buildings in use, that's quite a challenging amount of carbon reduction to try and achieve, as 42%. The other thing that I want to highlight about target setting is that many of the targets that are being banded around even today were set in the early 2000s. We're maybe going back now 10 years, but certainly and crucially we are going back before the great banking crash and the 2007-2008 economic downturn that began right across the world. And I think that that also is something we need to bear in mind as to how we're going to achieve these CO2 reductions, because a great play was made upon how domestic design could help to reduce CO2 emissions. But in fact, the number of houses that are being completed, certainly in Scotland, has been reducing over the years. Back in the mid-2000s, you might have been looking about 25,000 new homes in Scotland per year. Now we're down under 16,000. So all the predictions of numerous amounts of housing helping to reduce CO2 emissions are not being realised. And so there is a concern that, again, we may fall short of some of the original targets that were set perhaps 10 years ago. And of course the Sullivan report is reconvening in Scotland to review their targets and to review their programme, and that's much welcomed. The other thing that concerns me about the whole 2020 issue in Scotland is the fact that many people talk about, for example, 85% of our existing housing stock remaining in 2020. By my calculations, and I did them a couple of days or so ago, if you take only a 0.66% turnover or increase in the number of new build houses in Scotland, that actually computes towards a 95% value of existing housing stock will remain until 2020. It doesn't take into account demolition, but even allowing for that, that is substantially higher than much of the discussed 85% that we see in magazines. Now, I highlight that because clearly there is going to be a shortfall. The percentage of houses seeking to have better energy standards is going to be much less by 2020 than was predicted back in the early 2000s, and even now will be in the regions of about 95%. I think that's a crucial figure. Finally, the last slide that I want to present just at this stage is regarding the various other organisations that have been looking at some of very specific areas, and obviously NHBC are looking at housing, Good Homes Alliance in the housing sector, Carbon Buzz is looking at both domestic and non-domestic, but some of the issues that we're seeing that are very particular and need particular attention would be things like software accuracy and scope. These are things like SBEM and SAP. We know that there are issues there. In new build housing, there is the issue there with the NHBC looking to continue with their own investigation in the performance gap within housing only, but it is not obviously addressing issues in the non-domestic sector. Under systems and material performance, we are considering here coefficients of performance for heat pumps. There's issues there with the ratings that are often bandied about by some of the companies selling those products. Some of them do not really take into account either the source or the delivery temperatures. And so there are issues there that I think often skew the outcome of energy performance in buildings. And perhaps the biggest issue is post-occupancy behaviour. That, as I mentioned earlier, is a huge area for research. And I know that there are many looking at post-occupancy behaviour within domestic settings, but again, I come back to the non-domestic area. That is something that really needs, I think, quite a bit of attention. And so in general, I think this slide is saying to you that there is a much broader picture, and I'm not so sure if people generally are understanding the scope and the depth of the problem. And so we come to this part of the slide here, where really the scale, the scope and the detail of the problem is just simply unmanageable. And I think that there is a huge amount of research required to look at in much more detail the various areas that we spoke about earlier. I'm going to suggest to you that the main things that we need to do now really are these items in red, just before I hand you back to Julio. We really need to look at hard data. I know Carbon Buzz has made a start on that, and it's important. But we need to convert that hard data into coordination and collaboration amongst organisations. There's no point in just having it on a website for people to add to it. Yes, they can learn. Yes, they can find out maybe the reasons behind the gap between actual and predicted design performance. But we need to coordinate it much better within organisations. And that's not just within the construction, but that's within government policy making. We also have a lack of understanding, and therefore we can't legislate directly or effectively. And I would say that because at the end of our presentation, we will be making an appeal directly for funding that really needs to take this forward to show the government that many of the targets here, we may be sleepwalking towards 2020 without taking a very serious look at some of the gaps that we're now going to examine in a bit more detail. Just before we do that, I think we're now looking to Julio to give us a little rundown, I think on the next slide, on the existing literature that we examined as part of our study. Julio.
Thank you, Cameron. As Cameron just pointed out, it was important for us to, before diving into the real problems, to really explore what literature was out there, whether it was in the form of reports, whether it was in the form of websites, groups that were addressing such problems, and also post-occupancy results and surveys that had been done before, and really looking at some of the areas that were highlighted as problems. It was important to identify these causes through this existing literature. And really our focus, as it's been said at the beginning, was Scotland, looking at what has been done in Scotland, what buildings have been addressed, what problems have been encountered. It was also important for us to look into the Sullivan report. Although written and published back in 2007, before the kind of bank crisis, it does point out very important elements that have been highlighted as action points that I think could be important to kind of continue on. And in this situation, 2013, look at how it's been addressed and what to look up for in the future. And I think Section 1 and Section 7 in the Sullivan report highlight these problems quite nicely, and looks at solutions as well. But really it's looking at testing, it's looking at monitoring of buildings, coming up with a catalogue of results and benchmarks of buildings that have been assessed, and looking at occupational issues, etc., etc. So that was important for us to kind of read on. It was also good to start exploring other avenues in terms of different professions, both the design professions, the architectural profession, the construction industry as well as a core. And one of them was the RIBA and any publications they had, together with the Carbon Buzz, as Cameron has pointed out before, but also looking at how the RIBA plan of work, which is used in the industry as a guidance on and sequence of elements to take on board while designing and tendering, etc., how there is a gap there where the RIBA hasn't imposed a step for testing and monitoring of what's been built in any project. There is a guidance on design, there is a guidance on taking the project forward, but once it's been completed, there isn't that approach to seeing if it's performing properly. And we feel that is missing. And we also explored documents very similar to what we've been looking at. A lot of them published by the NHBC, which are the core of housing and standards of living and construction. And they've highlighted through the NHBC Foundation, together with Zero Carbon Hub, some interesting booklets and also papers on these elements of performance and where the gap is, and we make a lot of notes on that. They've also got a lot of literature around predicting and the software used for such energy predictions, which I think are also important. And also looking at post-occupancy studies, for example, the Elm Tree Muse developed by the Joseph Rowntree Foundation as an example of a building being assessed and really inspected very thoroughly in terms of its performance. But really, in conclusion, we've seen that a lot of the literature focuses on new build. A lot of the documents looks at domestic problems and buildings or housing developments that have been assessed, but not a mixture of commercial, non-domestic, and also retrofit. We feel that a lot of it has been focused on the new build sector. And we feel that retrofit has, in this day and age where there's little money for new developments, a bigger role to play in terms of achieving better standards, and also proving that any work that's done on retrofit is actually worthwhile and being important. So really, we move on to identifying these problems, and we've explored many of them. A lot of them around the design and the construction element, a lot of them around the prediction and also the actual testing of it, of buildings. So it's important to really look at these points and see where we feel that further attention and further work is needed in the industry. And through the diagram that Cameron was talking about with the different stages and the different typologies of buildings, we feel that could be tackled quite nicely. But I mean, the following are some of the areas that we feel are important. Already Cameron has talked about SAP as being one of the important tools within the design industry, and obviously the prediction of energy use of buildings. And that spans in from the fabric of building to the actual services that the building will have implemented into the everyday use of the building. But we've really got to put a lot of emphasis on the quality of the software, the information that it has, whether it's up to date, whether it is accurate enough. A lot of the times it's very generic in terms of the materials used. And as we evolve as an industry with more innovative materials and more innovative building procedures, this software seems to be lagging behind in terms of updating this information. Although SAP and SBEM is updated on a regular basis, we feel that sometimes it's not at the same rate. And sometimes it could be down to the type of materials there, the climatic data, or simply the technology that it has. We know that our industry is very flexible, it's dynamic, there's lots of new elements every day coming in, and it's whether these tools are as dynamic as well and accurate. But we've got different types of design-led tools. They could be dynamic in terms of the way we use its information embedded in the software, or it could be that we use dynamic, more effective ones, where we could do monitoring previously and input that monitored information into these software models and make it more accurate. So there's ways in which that can be in a better standard. Another element that we've identified is really the design-led aspirations and how complex buildings are becoming, and whether the design stage is willing to and is building up detailing and proper detailing for the construction period, for the trades to understand properly, for different sequences between construction, if they have been thought of during design. All that contributes to how complex the design is and the building will be. So that there has to be that understanding that whatever is designed has that thought of how it's going to be constructed, and generally that is taken on board, but a lot of the times that can bring some complexities later on, so that's important. Another aspect is a design-led specification. We could be specifying very generic and very kind of common materials that are known to us very accurately. But in other forms, it's relying on third-party information. We are on the hands of information and testing that we don't know if it's accurate or not in terms of materials and performance, in terms of systems and technology. So we're really relying on whether that information is accurate. And also thinking of that most of that information is before it's been implemented and before it's been led into the building and once it's been occupied. So there's that difference. There's the performance of a material or a technology before it's been used and once it's been implemented and used. So there's two different efficiencies as such that have to be taken into consideration. So that's something that we feel is quite important. And another topic is obviously on-site workmanship and the quality of build that we're having in the construction world. Are we relying on workmanship as it stands? Are the trades shifting? Are they modernising themselves to new materials, to new ways of building? To new standards, obviously. We're at design stage, we've got a set of guidelines that we've got to take on board. We've got to obviously have the SAP scores as high as possible. But is the building trade aware of this? Are they shifting with these standards at the same time as we all are? That's important. And that's where training skills and having these skills up to the higher standard is really important. Also looking at retrofit and whether we're aware of people being knowledgeable enough on older properties. Are the trades and are building professionals aware of older materials and how to integrate new procedures and new materials blended in with older materials? All that brings a lot of confusion on site, and if the proper people or the proper professionals are not engaged and briefed properly, that can bring in a lot of problems that will later be shown within the performance of the building and create this gap that we're trying to identify. And I mean, in the report we have quite a lot of examples that we've been involved in, both Cameron at the design aspect and the construction supervision and quality of build, and also ourselves in the Scottish Energy Centre looking at energy, heat loss, looking at elements in which it's quite evident where a lot of the gap could appear, and a lot of these are during construction, elements that have been missed or have just been badly installed. And we've got photographs here where, for example, there are gaps in the structure. There's concrete slabs that have not been filled properly for whatever reason. We've got pipe work going through different layers of the building fabric without considering air leakage around it, and different ways of sealing or applying some gasket around pipe work. We've got missing insulation in some areas, near the eaves, for example, at rooftops, where there's enormous big gaps of heat loss or thermal bridging, where there could be some obviously energy escaping itself. And onto the retrofit area, where we've got a complexity of generations or lots of different pipe work working in that is no longer in operation, but has to be mixed or applied to different more up-to-date pipe work. So that confusion within the trades and while dealing with retrofit is quite important. Gaps under skirting boards, etc., etc. All that amounts into this percentage of increased energy use, which has been talked about previously. And I mean, we also, part of construction is on-site communication. As we know, when we design, we aspire to that the project will continue with no problems, that the sequence that we've applied and that we've envisioned will go smoothly. But we know that once in construction, that doesn't occur. And that communication of any changes, of any stopping in different sequencing or changing in sequencing of materials or application of detailing has to be communicated properly to all the trades, so that this element of possible changes and problems within the reason for some on-site or construction problems can be mitigated as much as possible. And we've got elements that are kind of difficult to predict. When you've got client changes during construction, you've got architectural changes as well. You might have delays for weather, you might have delays because of the budget and the funding for such projects, etc. So all these amount to changes that need to be communicated around. And finally, we've got the post-construction testing that, together with the occupant behavioural patterns of buildings, are elements that are difficult to obviously predict. But the post-construction testing is important, because that will be part of the how we measure the performance, whether it's the fabric or the technology that's been applied. But that technology has to be performed properly. That testing has to be performed adequately, which requires accuracy and also experience on behalf of the people testing it. So that's important. But sometimes a lot of the methodology, because of the nature of the construction world and the industry that we're in, is focused only on new builds. So it's important also to link in and to drift into also the retrofit way, and how we can monitor retrofitted buildings, because it's a whole different ballgame in terms of building and materials, etc. So that's an element that has the quality of that is really important. And the occupant behaviour. difficult to predict during design time, and if predicted during SAP or SBEM or any other simulation or software, most of the times that occupational use or pattern is modified, let alone the unregulated use of energy that is not taken into account in a lot of software these days. So all that accounts into how the building will be used, and eventually how much energy will be used in the building. So that's important, and that's where social patterns come in. You've got different elements of predicting this, and really having also technology that can measure the actual energy use, that can later on give us information on whether it is as accurate as predicted. I'm going to pass on to Cameron to talk a bit about our approach into shrinking this gap after identifying all the different elements of problems.
Thank you very much, Julio. I want to chat just for a moment about the diagram that we have on the screen here. Let me just pick up the little arrow here, which hopefully we'll be able to... Do I have to click that there? Is it a click and drag, or...?
It should be once you click it in, but...
There we go. Yep. Right. This little diagram is meant to be the three-dimensional conversion of the two-dimensional tree that we were discussing earlier in the presentation. We took that two-dimensional tree and we've put it into this X, Y, Z coordinate system to show along the X coordinate here the process as might be followed by, for example, RIBA plan of work over time. The Y-axis, which is just indicating the difference between domestic or non-domestic commercial within each project, and the Z dimension, which is really taking the variation between anything that may be regarded as new build up to refurbishment. And so within this three-dimensional modelling of the problem, we began to identify the various areas where the research strands would be fitting. And so you can see here that the numbers in each of the corners relate to the various 12 research strands that we identified earlier. And within each of these planes, you can begin to see some of the issues that will be occupying some thought regarding, for example, in the management section, things like occupancy patterns, commissioning tests, and post-occupancy evaluation. And so you can see three-dimensionally here the complexity of the whole performance gap issue from start to finish across all sectors, across all types. I don't really want to dwell any more on this diagram, save to say that you could, for example, look at it perhaps after in replaying this webinar. But it is important because it starts to model the problem. Julio and I, in beginning this initial modelling stage, may well take this further and start to develop some more ideas about it. But it is a first stage, and it came out of much of the research work that Julio has been describing in the past 5-10 minutes. So I'm going to pass back now to Julio just to take us through some of the other slides which lead us into some of the approaches that we identified to start to shrink the gap. Julio.
Thank you. Well, I mean, as we know, as I've identified before, we could probably differentiate the different approaches together with that model on the fabric performance, on the technology and the services performance, and also on the occupants approach and occupancy patterns. But we know that fabric performance could be described as a kind of known science in terms of how we calculate U values, how we identify heat loss, and how we can try and reduce that kind of wasted energy in a lot of our envelope around buildings. And there's a big distinction between new builds and retrofit, where new builds you've got a bigger scope in terms of a design stage where you can plan and obviously better model a building, and in retrofit you've really got that element of investigating what we have and making a survey of the actual current performance of the building. Both of which obviously have different solutions and different approaches. But fabric, obviously addressing fabric is really important, and that's one of the areas where we feel there has to be more focus on. And from predicting and monitoring using infrared thermography and looking at ways of insulating properly in retrofitted buildings, or from the actual new build aspect of really detailing as close as possible any junctions or any elements. But there are areas where while we're predicting, while we're designing, are very difficult to really model, and it could be from repeated timber studs, for example, in a structure. We could very easily design something that is every 600 centres and doesn't really have any problems on the predicted side. But once we get on site, once we're building that, it might be that there could be repeated studs for whatever reason, because of the sequence or because of various changes on site, etc. So that might change the phenomena and just the way that wall or that envelope might work. And we know that by having these elements, we could have more heat loss and more thermal bridging. And that is the same in junctions, and having different areas of thermal bypass, for example, in walls, adjacent walls, and having ventilation shafts, etc. All these elements are very difficult to model and to predict. So there needs to be more focus, more information on that. And it's also looking at how in situ testing can be fed back into software and really getting some more information on that. And that is where a lot of our studies at the Scottish Energy Centre have identified that in fabric performance, the use of U values, predicted U values against actual U values, and the disparity there is enormous in some instances. The same goes for building services. We have now more of a complex approach to buildings. We have these so-called intelligent buildings, from the actual controls of the buildings to the actual use of energy, whether it's for obtaining energy, the use of renewable energy and renewable technology, to the actual zoning and the use of whatever heat or electricity that's been distributed around the building. So we have a vast majority of complex systems these days in our buildings. But we know that with an enhanced fabric, with a better detailed and better insulated fabric, the heat loss will be less, therefore our need for energy will be less. So the sizing of building services and technology could be smaller. So elements like those and that analysis of building technology and services is key. And also trying to get a lot of the tools and the prediction tools, for example SAP and SBEM, to adapt at the same rate as a lot of these changes are occurring with new materials and new technology out there. So simulation of these is important. Refurbishment is important as well in trying to implement new technology, new pipework into current installations, and the way we survey that and the way we look into that is vital as well, and hopefully that will reduce this gap in performance. But also maintenance is a key part of building services, not just sizing a technology, but also how we're going to have a maintenance regime that can be set at the beginning of building, during early occupation, and maybe at set times around the use of the building. And finally, it's the building user. It's this problem of making the building user aware that there's new technology, there's new there's new fabric being implemented in the building. Therefore, there needs to be a different use of the building in terms of using energy within it, and the behavioural patterns within it. A lot of designs are designed with an occupant numbers and use, a specific use to a room or a building, and in many occasions the end user might change their mind, or the change of hands of different properties changes the use of different rooms, and that can bring in different occupational patterns. So those have to be as flexible as possible during the design stage.
Could I just reinforce a point there on that particular slide? Yes, I think if you go forward one, Julio. And it is in relation to Carbon Buzz, because I would advise people to have a look at the Carbon Buzz website. I think it's a good platform for information. And one of the things that I particularly like about it is that it identifies two key issues in mostly non-domestic properties. And those two key issues that tend to bump up the CO2 emissions are lighting and unregulated electrical use. Lighting is an obvious one to understand, because very often people just walk out of the office and they've left the lights burning all evening, and that does tend to bump up the electricity consumption, energy demand, and therefore CO2 emissions for that property for that reason. And that is something that really needs to be tackled, non-domestic especially. But it's the unregulated unregulated electrical use. This is all the appliances used throughout offices and factories, but also in the home, anything from TVs to all the handheld devices that we use. There is nowhere within the SBEM or the SAP calculations are you actually able to monitor or put in the information in relation to that type of use. One house may have heavy use on that unregulated electricity. Another house, perhaps with just one person, may not. It's very difficult to predict. I suppose there needs to be some guide put in initially to the SAP calculations as to what you think the the unregulated energy consumption will be for any property. But very often, according to the Carbon Buzz website, that is something where there is a huge disparity between the designed element or understanding and what actually happened by way of the building user using that power.
I think also around that topic is really the understanding of the building user of the building, and that's where the use of building guides of how to use your building, especially as when it becomes so complex, is quite important. And really a lot of it's been applied in a lot of housing complexes by housing associations, etc., where you have a user guide on explaining every element of use of the building. A lot of the times these buildings or a lot of technical data is very blurred and not user friendly in terms of using new technology. And that is where a lot of disparity on the actual use is important, and the evidence is a kind of increased energy use once it's been occupied and throughout the years. So I'll hand over back to Cameron on some final points.
That's fine. Thank you very much, Julio. I'm just going to take through a couple of slides before we come to our conclusion section. This particular slide on building industry change is really just identifying, I think, that in general there is a huge need for a cultural change in terms of the way in which both the designers and constructors, as well as the building occupiers, all of us need to take a huge, long, hard look at what we're doing in much greater detail than we have done in the past. All of us will need significant training to be able to come to terms with the standards that we should be working to if we are to achieve the targets by 2020. And also, in terms of the continuous improvement factors, we wanted to just summarise a few points here. We've spoken repeatedly about post-occupancy evaluations. I know that a lot of that does go on, especially within the housing sector. That is something that really does need to be examined much more closely in the non-domestic sector, because I believe, even just glancing at the Carbon Buzz website, that is a significant problem. And also in terms of the completion certificates that are given to properties, both domestic and non-domestic. Julio and I were talking about this just actually before the presentation, and we were just discussing the fact that in many completion certificates, certainly within Scotland, you have to submit sometimes now air test results, acoustic results, you have to have an electrical compliance certificate produced for the council, but nowhere along the line is there anything that relates to energy, in the sense that there is no in-use submission. You will of course have your SAP and your SBEM calculations as part of a warrant submission, but in terms of the comparison between that designed or predicted energy consumption and the actual on-site, there is no going back to building standards after completion. Once you have that completion certificate in your hands, there's no going back to have to account for the building's performance. Of course, there is now the energy performance certificate, which is to be displayed on properties in the reception entrance area, which will indicate ongoing monitoring and performance of the building to users of the building. But by and large, Julio and I were just discussing whether or not there could be or should be some mechanism for bringing together the energy likelihood of that building at the completion stage, and the council being able to have a better handle as the verifier on the performance of that building at completion.
And I think that's where the RIBA plan of works could be quite important, in that could be added to the last stages of the plan of works during the design course and construction.
Mm-hmm.
But just on the conclusions, really we're preparing ourselves for better standards, better building regulations, and there's no better time than this one to really recognise these elements that are kind of increasing this performance gap and trying to tackle them. It could be on an industry and individually, the design professionals, the construction, etc., or it could be as a whole, trying to address these points and really trying to minimise this gap as possible. And the Sullivan report, they are reconvening. It would be interesting to see if more focus and more emphasis is on this benchmark of performance, so that people could relate to that, whether it's during their modelling and design stage, or whether it's on a post-occupancy side. But we feel that the Sullivan report should be addressing this, and hopefully the expert panel that is come up can do that. But at the end of the day, we need more data, and that's where benchmarking is important. We need more data also on materials. There's no use in just having data from older lists and older materials. We need to be testing more materials. We need more testing facilities in Scotland. That's important for us. A lot of the manufacturers and a lot of the products that are developed in Scotland have to be tested down in England, which is a big cost for companies, which makes obviously the quality of the products quite important. So we need that in Scotland. We also need this collection of materials and embed them into more up-to-date software. Climatic data, we need all that is important in order to kind of bring this performance gap predicted, at least at the beginning, as small as possible. And I mean, this model again, we feel it's important to kind of introduce, really to recognise these points, and also have this all these stages that have to be addressed within the design, construction and management, which we feel is really important. But refurbishment is important as well. We know that there's new funding mechanisms out there, the Green Deal, the ECO, that rely on predicted performance. And sadly, a lot of those predicted performances are linked to an economic and a cost model that will rely on these predictions. If after the work has been done, these predictions are not true or are just not performing as stated, the economical payback will be enormous, and a lot of people will be quite aware of that and not really engage on these elements. So this is important in terms of refurbishment. And I think some final slides and aspects from Cameron.
Thanks, Julio. I've got my eye on the time, and I'm looking to just close over in these last couple of slides. I'm not going to go through the detail of this slide on the screen just now. However, what I want to do is briefly describe to you the process of getting from this stage to this stage. This will be, if you like, a scoping exercise to be able to start to gather that information, which will then enable us to provide the information for setting up better modelling techniques, for looking at government policies and also government legislation. Once we have been carrying out this scoping exercise, it will begin to start to help feed into more focused research work. It will give us a proper understanding and base from which we will then be able to coordinate different organisations or different people who are looking at specific areas within their own silo of information. They will be able to share that, because as you can see from the three-dimensional diagram we had, there is a great deal of cross-fertilisation within different sectors, within different building types. And this, of course, then, from the research, will lead to action, and that is the final part of this slide, which is about making sure that all of us as designers, as constructors, and as building operators and managers will have a cultural change which will significantly lead to the reduction in CO2 emissions. And finally, a slide that I'm just going to leave with you, and I just want you to take for 1 second a moment to read that text in red. I wrote it perhaps on the spur of a moment late one night Just read it. It says the danger is that within the construction industry, that's the building people, and building management, that's all of us continuing to operate our existing houses, carbon reduction and energy efficiency could well plateau well before 2020. That is, I think, one of the main concerns we have, and I believe in my heart that much of what we've shared with you today, the reason why we may fall short of some of those targets, is simply because we are not engaging properly today with where the gaps actually exist. And I think it is perhaps the main aim today is to share with you those gaps, share with you the thinking, so that perhaps all of us can start to focus our attention, whether we be designers, constructors or users, to be able to focus our information much more so. So that is the final slide, and I want just to thank Branka and Craig and David, who are working behind the scenes, for all their hard work in helping to put this webinar together. So from Julio and myself, thank you very much. Thank you, Branka.
Thank you very much, Cameron and Julio. And we will now continue with some questions and comments from our online viewers, and I would encourage them to submit their questions by using chat facility. To start with, we have three comments from Tony Cowling of Tony's House, who agrees with your presentations and comments, and brings up a few of his examples and concerns. For example, he says, my main concern is the use of internal linings in masonry-built homes, i.e. blobbed and dubbed plasterboard, allowing air infiltration on a grand scale, leaving the occupier living in nothing more than a plasterboard tent, albeit with the majority of the insulation in the walls being thermally bypassed. Or let's just continue with his examples. Heat loss by design, party walls is still a problem. Typically, party walls are uninsulated and air leaky, connected to outside air, leading to heat losses that are not allowed for in calculations. And final comment that he gave, how many performance tests are conducted during construction? 0.1%, like almost none.
Yeah.
So just your first comments or replies to his
Well,
examples.
I mean, I think Tony has highlighted a lot of problems within the fabric of buildings, and heat loss and ventilation shafts within solid walls and all their properties is quite an important aspect. They all account into building retrofitting, but it's making a proper survey of the building, especially in retrofit, and looking at areas where we should be dealing and improving is important.
Yes. I don't have anything to add to what Julio has said.
Question from John Stinson of Scottish Energy Centre. I'm curious, and perhaps the speakers could elaborate. Has your research to date highlighted three core areas to the performance gap, i.e. calculation gap in the numerical building design software, then responsibility gap in on-site building practices, and education gap in end-user behavior? And do the speakers feel that there is a gap that is more prevalent than the others?
Well, I mean, those are the three kind of main areas. It's the design or the prediction, it's the construction during, and it's the occupancy. I feel that the occupancy one is a difficult one out of the three, mainly because we're dealing with obviously people that are not technically aware, most of them, a lot of them, who are landed with a new building that is supposed to be sustainable, so supposed to be energy efficient, and they've not got that awareness from the developer or the housing association, or in the case of commercial, of the builder, on how to operate that building. Or how to really live with it. So that's important. I think that's a tricky one out of the three.
I think the answer to the question could I suggest is definitely is yes, it is, but it is slightly broader than that as well. I think on the design front, it's not just about the calculation, the SBM and SAP. It's also about many of the decisions that we as designers often take in terms of the specification, in terms of the systems that we might put in. Many of us at times misunderstand. Many of us misapply. Many of us put together a concoction of systems within houses, some of which work against each other. So it's not just about the calculation and the predicted modelling, it's also about designers having a much better understanding about the systems that they are proposing, and the specification of the materials, and also the manufacturers out in industry, about them being realistic about the coefficient of performances, especially of heat pumps, being that is such a huge problem area. Within the construction sector, it's not simply about the ability of people on site to put things together in new and different ways, but it's actually, and we didn't really speak much about this, although Julio and I have obviously discussed it during the research project, is really about the growth of off-site construction and the various systems that building constructors are bringing into the market, especially within the housing sector, because by and large some of those large off-site fabricated panels coming in, like the SIPs panels, they will bypass a great many of the kinds of problems that the earlier inquirer was speaking about, whereby you're looking at on-site fixing. You've already got all of that with off-site construction, and there's very little to go wrong and very little for people to be able to fudge on-site to create the problems. So it's not just about training of operatives on site, but it's also across the construction industry about encouraging much more off-site fabrication, which gives more of a guarantee. And in terms of occupancy, yes, it is about educating the occupants of their buildings, but it's also perhaps there's opportunities for people to come to the market with more inventions about how lighting can be controlled, about people being encouraged to put in sensors and controls within their properties on day one at the specification and design stage, in order to bypass the poor behaviour of occupants who will just leave lights on. If we can get on top of that by using other techniques, and also of course in terms of unregulated energy, well, I don't know how, I mean there must be a myriad of inventions that could be made to try and bring that under control. In general, the answer to your question is yes, but I think it's slightly broader. There are those three core elements though.
More comments and questions. Dr. Obux Ijah, who thanks for the presentation and has questions because he's involved in research entitled Awareness of Energy Retrofits Owner-Occupied Houses in Developing Countries. Some of his questions emerging are as follows. First of all, the role of BIM, Building Information Management, in the future of this, or modeling, in the future of this kind of research. They have some expertise in there might be a scope for collaboration, which you can follow. A question, what is the real cost implication for the homeowner? And finally, he thinks that the focus should be on retrofitting, since there are fewer new buildings. Adding also that homeowners are not sold on the incentive for cultural change, and that is a challenge that is emerging from their ongoing study. So a few potential collaborations there. And one more question from Morgan Green of CAF. Do you not think that if design and construction details were submitted at planning stage for approval, the gap between design and construction would automatically decrease?
I was aware that was the way the design and construction details are.
At planning stage.
Oh, at planning stage, okay. Before, to have a bit more time, yeah.
Yeah.
Well, you wouldn't typically show construction detailing at planning stage.
Yeah,
some planners may ask for specific details for a specific look on appearance on a building, but generally speaking it would be at warrant stage. It's funny because one of the seminars that I was at recently by a Scottish Government-based website was identifying the fact that actually, and this is an interesting point that last comment person raises, is that very often the most significant savings that can be made in reducing carbon dioxide into the atmosphere will be made at the strategic planning stage. Yeah. The earlier you make decisions about that, the better. So it somewhat reinforces that earlier comment, but obviously in terms of detailing, there's not so much at planning stage, but the commenter is right.
A question from Jennifer Sansfield of Page Park Architect. Do you know of incentives for building owners or contractors to pay for POE or post-construction performance testing prior to there being a statutory requirement?
No. I mean, I know there's the Technology Strategy Board. They had a good run of POE funded projects. Obviously, there's an application behind that and selection. But other than that, and at that stage, I'm not aware.
No, I'm not aware either, except I know that CIC have certainly funded a number of specific post-occupancy evaluation studies for a variety of people over the years, and there is certainly, through the academic consultancy, there is certainly that, but I understand that programme is now coming to a close, obviously. Yeah. Can I pick up a few of the points that were made? There was a gentleman, I think, made some comments regarding a whole variety in some of the emerging countries. Yes. Am I right in saying that? Yes. I would agree with a great many of the points that he raises. Certainly, retrofit it obviously has to take centre stage between now and 2020 in almost all the developed countries, certainly in the EU. Retrofit has to take centre stage. Cultural change was another one that was touched on in some of the comments that were made. I think recently I heard, or rather I read in an article in a magazine where it said that culture eats policy for breakfast, and I think we all have to be mindful of that. Culture devours policy for breakfast. You can set any amount of legislation, you can set any amount of policy making. At the end of the day, it will be dictated by how we as designers, how contractors and how building users will implement that. That is what will be the issue, and I think hopefully today, in airing and discussing a lot of the issues we've spoken about, we will raise the profile of that for all of us involved.
A question from Emilia Conte of Polytechnic University of Bari in Italy. About a gap more prevalent than others, might it be useful and possible to associate a weight to different phase, design, construction, management, so to understand where it is better to invest in a specific context in order to effectively bridge the gap?
Yes. I don't know, I might be able to put my hands on it straight away, but one of the other things that, here we are, this isn't on the presentation, but if you can see that on the camera, you can begin to see that we've already predicted this. Just here is my idea of some of the shading and the weighting by using colouring, just to see where the most effective investment can be made into either research or site work or design work or the improvement of the software. Begin to see through this sort of diagram here exactly the point you're making. I think it's a good point, and it's part of that second last slide that I showed. If you go back to that second last slide, you will see how the process is meant to help to bring out, for government investment and government research, bring out the areas that are going to deliver the most effective energy reduction between now and 2020. And I believe that we do not have in our possession at the moment sufficient data or understanding to be able to declare that confidently. I think that that is why today we are anticipating that we would like to have further funding for further research to build up a stronger picture, to be able to influence government decision making and therefore legislation. And I do agree with many of the comments that have come in that there is a dire need for that.
And I think that's where the monitoring, the post-occupancy evaluations, and having this catalogue of projects and products as well, that can feed into this weighting side of things, and looking at the importance at different stages can be really kind of key to giving the priority to the different problems. So.
And although there is an issue with cooling in buildings, and that may be more prevalent to southern European countries, obviously our presentation is very much a Scottish-based thing, and the further north you come, even coming out of England and the Carbon Buzz RIBA CIBSE platform, there really isn't anything in Scotland that we believe is beginning to help act to be able to present that information. So it is very much a Scottish thing that we're talking about here, and clearly it has a much greater impact in terms of energy consumption in our colder regions here than it does as you go further south into Europe. But there's obviously the cooling issue there.
Thank you very much, Cameron and Julio. And as we will soon have to close the seminar, we don't have any more questions. I would like to thank our speakers and our online viewers for their questions and contribution to the discussion. I would also like to draw your attention to our forthcoming events. First of all, there is a webinar on 23rd of January. The title is Sustainability and Energy Efficiency of 3 New Build Dwellings in Edinburgh in Fife. And our speakers will be again Julio and his colleague John Stinson of Edinburgh Napier University, and Stuart Hannah